If you are new to the GPR, then this video is for you. In this video, I'm going to discuss how you can set up a 80 megahertz GPR antenna, and this will be the second part of three-part series where I discuss about how you can set up a GPR antenna. So in the first part, I have discussed how you can navigate through the control unit and how you can set up a 200 megahertz antenna. So if you haven't seen that video, go, the link will be in the description. Go and watch that video, please. And because I have discussed in details in that video what are the parameters you have to set up, what are the some menus you will be having or you will be encountering in the control unit, or what are the ranges or what the significance of each point, I have discussed in detail. So if you haven't watched that, go and watch that video. Okay, so this is the second part where at first I will be discussing what is an 80 megahertz antenna, then I will be discussing how you will be setting up a collect mode parameters. So as I have discussed the parameters and its significance, or the points I have discussed already in detail, so this will be a very short video where I will be discussing the suitable ranges for 80 megahertz antenna. Okay, so let's jump into the video. This video I'll be discussing how we can set up a GSSI SIR 3000 system, and the antenna you will be setting up that is that has a center frequency 80 megahertz. So at first let me tell you about the 80 megahertz antenna. So this antenna will be coming in two boxes. Basically, other than the control unit, you will finding two boxes. So one box will contain your transmitter and receiver component. Another box you will find, it will be a long box around 5 feet. Okay, so let's say you'll be finding several antenna elements within box or within this box, and it'll be among which some of them will be the telescopic, and you will find two orange colored, regionally provide orange colored, okay, two orange colored antennas, and those two antennas will be for 80 megahertz. So antenna, the basic characteristics of 80 megahertz antenna, that the central frequency will be 80 megahertz, clear, and the total length of this antenna should be 120 centimeter. Okay, so the model I'm discussing here, that model is called model 3200 MLF. It's given by GSSI, not me. And these two you are seeing here, a transmitter and the receiver component. These orange color rods, these are basically your antenna elements. These orange color rods are your antenna elements. Okay, so each of the rod, so there are two antenna component like transmitter, one is receiver. Okay, each of these antenna components will consist of two elements, two elements, two elements. Okay, okay, and these two elements, each of them will be 60 centimeter long. So what will be the total length of this antenna from here to here? That will be 120 centimeter, along about 4 feet. So one characteristics of 80 megahertz antenna is that the is length is around 4 feet, or to be exact 120 centimeter. Got it? And the loaded pulse width for this antenna will be around 12 nanosecond. Got it? So that's the characteristics of this 80 megahertz antenna. So it's a bistatic antenna. There will be separation between transmitter and receiver. And what should be that is separation between transmitter and receiver? That should be at least 1 meter. Okay? The separation between transmitter and receiver should be at least 1 meter. Now let's discuss about the collect mode. I think you remember from my last video that I have discussed for 200 megahertz monostatic antenna. Here you will first option you will be encountering, that is radar. Under this radar menu, you will be seeing that what antenna type you have to select. For 200 megahertz antenna, I have already discussed that from the drop down menu, you can select 200 megahertz antenna and you are done for the antenna choice. But for 80 megahertz antenna, you won't find any option for that. So for 80 megahertz antenna, your antenna choice will be custom. You will be selecting custom. Second point is under this radar menu is called T rate. T rate means transmit rate. I have already discussed about this. Again, same thing I'm not going to discuss in this video. So I'll suggest you go and watch that 200 megahertz antenna video. And so the transmit rate for 200 megahertz, what I said, the transmit rate for 200 megahertz was 100 kilohertz maximum. Okay. In this case, the transmit rate is 12 kilohertz. You cannot do anything because it's specified by the manufacturer. So that's the maximum transmit rate you can use in 80 megahertz bistatic antenna. What would be the mode? Several modes, three modes I have discussed: point, distance, and time. Um, so again, I'm repeating this, but go and watch that video I have discussed there. So the mode you will be selecting here is point mode. Related to GPS is that GSSI has also provides GPS separately, and their GPS named or compatible with this system is G30L. So if you attach G30L, you'll be choosing or selecting G30L from the drop down menu. Or if you don't have that GPS, you can use, if you have your own GPS like not G30L, then you can use custom. Okay, you can choose custom. Or if you don't have any GPS, then what will happen? Then I have already, then you'll be selecting none if you have no GPS. Next sub menu is samples. Samples mean is samples per scan. Samples mean samples per scan, and it could be of several type depending on samples per scan. Your survey time or data taking time might increase or decrease. Okay, so it could be 2048, it could be 1024, it could be 512. I'll suggest my suggestion. If you want to know my suggestion, then it is 1024. That should be the ideal one. Don't take too much, don't take too low. Okay, so sample per second should be 1024, and this format could be of 8 bit or 16 bit. Okay, so 16-bit will take more memories. If you increase the number of samples, then it will, if you increase it, then it will take more memory. Okay, and similarly, if you increase the format 8-bit to 16-bit, it will take more memory. But it doesn't matter, you will have, I've already discussed on this, so don't worry about the storage. So you will be going with the 16-bit. So what I've said so far, that in samples you will be choosing 1024. Okay. Format you will be choosing 16-bit. Got it? Now what would be the range? Range means the time window in nanosecond in which that your control unit will record the reflections, will control. So the range means is the time window. And this time window is in nanosecond for 80 megahertz antenna. What will be that range? The range GSSI suggested 400 nanosecond. I'll say choose 500 nanoseconds so that you can see the maximum depth of signal penetration. You can see that line. When you are surveying an area, you have to collect more data information possible. Okay. So you will be choosing, let's say you are selecting 500 nanosecond. So in case of dielectric constant, it does not matter during your data collection, but you have to put a value, and I'll suggest you put a value 10. 10.0 is your dielectric constant. Why it doesn't matter? Go watch my previous video. So let's talk about rate here. Rate means your scan per second. Okay, per second, how many scans you are taking. This is important when you are uh, doing a time-based survey. In this case, you will be writing or you will be keeping scan per second either 8 or 32 or 64. I'll suggest you will be keeping 32 here. Okay, clear? Next is very important, that is scan per unit. Scan per unit basically defines or defines your station spacing. Okay, so you are surveying like this is the transmitter, this is the receiver first point, T0 or 0. Second, you have taken T1. This will be the receiver, R1, okay, and so on. The spacing here, let's say 10 centimeter. So scan per unit, and suppose you have set up unit in meter. So it's basically giving you the idea of scan per meter, how many scan you are taking per meter length, okay? And suppose if your station spacing is Tx equals to 10 centimeter, then scan per meter you have to set 10. Okay, 10 will be your scan per meter. This gain here under the scan menu, this is for the display purpose. So you can put any value to see what type of data you are collecting. Okay, to see or to highlight the data. This is for only for the display purpose. It doesn't have direct role in the data collection. Next sub menu under collect menu is gain. Okay, so gain, you are seeing here that gain could be of 5-point gain. You can use maximum. So you can do 3-point gain. The example here given here is 3-point gain, or you can do it in a 5-point gain. And how to set up gain automatically? First, you will be, if your gain is in auto mode, then you will be doing it in a manual mode. Okay, and then you will be going for again for the auto mode. From the drop down menu, first you will be selecting, if it's in a auto mode, you will be converting that, or you'll be selecting the manual mode. Then again you will be doing the auto mode after setting up all your electronics, after setting up all your system properly. Okay, so that it can configure automatically. So this gain will be configured automatically, just like 200 megahertz antenna. Okay, next sub menu under collect menu is position. Okay, so this point is basically defines, or this point basically controls the point zero, sorry, controls the time zero position. So it's basically controls the time zero position, and here you will have two options. One is offset and another one is surface. So offset basically define, I've already discussed in details in the last video. So offset basically decide the direct wave arrival, okay, direct wave arrival position. Okay, so if you see in the oscilloscope, that's the first break. So I'll suggest take offset here. That will be your offset. Okay, you can by changing the value here, okay, you can change the position up and down of this cursor, and finally you can press the OK button and you will get the offset value, so which will be related to the direct wave. And another one is called surface. Surface basically gives you the idea, or it locks the position of ground wave. If you don't want to, if you do not want to take this I mean, so if you see on a radargram, you'll be seeing first to a high amplitude reflection first, that is the direct wave. Then you will be having the ground wave. If you don't want to keep the direct wave or other flat parts above the ground surface, then you will be positioning your cursor here. But my suggestion that you keep the you keep the cursor above this first break, so that you can understand where the direct wave comes in, where the surface ground wave comes in, and later if you want you can remove those during processing. That's my suggestion, that do not remove those during field correction or field data collection. Clear? Last point on collect mode is filters. Okay, and filters is very much important. This point you should know what you should select for a particular antenna. Okay, and for 80 megahertz antenna, you know, if you have seen my past videos, if you have seen my previous videos with 200 megahertz antenna, then you might know that I'll suggest that you go for IIR, and here you'll be selecting low pass IIR. For 80 megahertz antenna is 160 megahertz. Got it? And for high pass IIR, it will be around 20 megahertz. So you are selecting low pass IIR 160 megahertz, high pass IIR 20 megahertz. Okay. Stacking. Next important point after setting up the filters is your stacking, and the stacking could be of of it might be 32 or 64. Any number of stacking you can take. But here is the catch for 80 megahertz antenna. This is very much important. So 200 megahertz antenna, if you select 64, it doesn't matter. It won't take much time. But for 80 megahertz antenna, okay, so if you take 64 higher stacking number, then it will take much time, really much time. So you are doing a point mode survey, and if you are doing 64 stacking, then it's going to take much time than 32. And when I say this much time means is in a couple of minutes, like 4 to 5 minutes or more than that. Okay, so you have to wait 5 minutes to take one data. The progress bar will be showing, it will be very slow, and you have to be fixed on that position for so long, and it will take much time. So depending on your aim, please decide which one you want to take, 32 or 64. At the last point on these filters is BGR removal, that is the background removal. And I will suggest do not go for background removal. Don't do the background removal. If you want to do background removal, do it in your software. Okay, you take the raw data, you do the background removal in Redon 7 or any other software you got. Okay, so that's it for today. Thank you very much.